Hi, Assalamualaikum. My name is Nur Afika binti Abu Safyan and my metric number is 199077. I am from University Putra Malaysia. Today I'm going to present my proposal entitled Abelian semigroups are subspace hypercyclic of matrices. This is the overview of my presentation today. There will be 5 parts. The first part is introduction, which include research question, scope of research, objectives. And the second part is literature review, where I compared the articles that I found which are related with my topics. And the third part is a methodology. There will be 2 theorems, and the fourth part is my expected results, and the last part is the references, all the articles that I use. So we move on to the first part, which is the introduction. And a semigroup with an identity inverse and commutative is called an abelian group. An abelian group is a set whose elements are related by a binary operation that is closed, associative, and commutative. Thus, all abelian groups are semigroups under the same operation. All abelian semigroups are not necessarily a subspace hypercyclic. There are few methods to determine whether the abelian semigroup are subspace hypercyclic or not. In this paper, we will show one of the methods that can be used to solve this problem. For some abelian semigroups that are subspace hypercyclic, it actually can form a hypercyclic abelian semigroup on Rn. So in order to solve this, the minimal number of generators of a finitely generated semigroups are required to form a hypercyclic abelian semigroup. So my research question is, can we conclude that all abelian semigroups can form a hypercyclic abelian semigroups by finding the minimal number of matrices? So there are two my scope of research. The first one, we will be focused on abelian semigroups only, and the second one, we will computing all the theorems by Feldman theorems only. The objectives of my proposal are: first, to provide an effective way of checking that all abelian semigroup is subspace hypercyclic. Second, to prove that the minimal number of matrices required to form a hypercyclic abelian semigroup having a normal form of length r plus 2s is exactly n minus s plus 1. So my literature review. This paper aimed to prove whether all abelian semigroups is a subspace hypercyclic. If there is an abelian semigroup that is a subspace hypercyclic, we want to show that it can form a hypercyclic abelian subspace. So for the first article from Ayadi and Marzugi, they applied Feldman's theorem to solve the problems in their research. These theorems are used to calculate the minimum number of matrices to form a hypercyclic abelian subspace. Hence, we can use this method to find the minimal number of matrices to form a hypercyclic abelian subspace. Next, from Bemerny, Cadets, and Kilichman, they also mentioned that they answered an open problem about whether every hypercyclic operator is subspace hypercyclic affirmatively in their research paper. We also can refer to the method used in this article when we want to prove that all abelian semigroup is a subspace hypercyclic. In other research, a researcher showed that if a finitely generated abelian semigroup D of matrices over C is hypercyclic, Then for every k equals to k1 until kp element of np naught, gk is hypercyclic. Then from the fourth article, which are written by Herzi and Marzuki, they stated that they proved a theorem to determine whether a similar result holds for subspace hypercyclicity based on the what the researcher before found. We can also use this theorem to determine that an abelian semigroup is subspace hypercyclic. Back in 2017, Marzuki also mentioned about normal form of G. Actually, the normal form of G means that the semigroup G has a normal form of length r plus 2s, has a normal form in Rn for every partition n with length r plus 2s. This is also actually the same method as mentioned in article 1 and 2 by Ayadi and Marzuki. Readers can also refer to the references 1 until references 5 that I provided at the reference part for more information. There are many different methods that the researchers use about this topic. So we move on to the next part which is the methodology. As you can see, this theorem 3.1 can actually we can use this theorem to determine whether abelian subspace is a subspace hypercyclicity. This is actually the theorem that I found in the article number 4, if I'm not mistaken. So for this one I will try to prove whether abelian semigroup is a subspace hypercyclicity. For the next theorem, this is where to prove that we want to prove that the minimal number of matrices required to form a hypercyclic abelian semigroup having a normal form of length r plus 2s is exactly n minus s plus 1. This theorem also I found from the article number 1. Yes, article number 1 and 2. So I will also try to prove this theorem for the with its corollary, whether it is true or not that n minus s plus 1 is the minimal number of matrices required. So next, the expected results. We expect to show that not all abelian semigroups are subspace hypercyclic. This is what I mean by these results is, although we try to find that all abelian semigroups are subspace hypercyclic, but I want to show that actually it is not all abelian semigroups are subspace hypercyclic. So the second expected results is the minimal number of matrices required to form a hypercyclic abelian semigroup having a normal form of length r plus 2s is exactly n minus s plus 1 are expected to be proved by the proposed theorem. For for this second expected result, I will try to prove that this is the exact answer by the proposed theorem. But for the second theorem, we only can use that theorem if the abelian semigroup is a subspace hypercyclic. But if it is not a subspace hypercyclic, so we will not use this theorem. So this is the references that I use in my proposal. This is the first, second, and the third, and this is the fourth and the fifth references that I use. So that's all from me. Thank you.